Continue with mixture problems, but we're no longer going to look at solution problems. Now we're going to mix up things, but they won't be liquids. We only look at two kinds of mixtures in this chapter. More are in the chapter, but we just picked two of them. What we're going to look at are, first of all, ticket questions. The first two questions, when you go somewhere and you buy a ticket, isn't it pretty common that there's one price for adults and one price for children? Mm-hmm. Now, I've always kind of wondered about that, because isn't the seat the same size? You know, it doesn't matter how much of it you're filling up. It's the same cost. Now, maybe they're just trying to motivate parents to bring a bunch of kids, so they reduce the price a little bit. Whatever it is, they're different values. Usually adult tickets cost more. Okay, so we're going to look at some mixtures of tickets. That's going to be one kind. That's 1 and 2. Then we're going to look at 3 and 4, and those are mixtures of coins. Because in our money system, different coins have different values. Just like adult and child tickets have different values, nickels and dimes have different values. One example, and there's not one in your math lab, but believe it or not, people like Planters peanuts have to worry about mixture problems. Have you ever bought a can of mixed nuts? Every different kind of nut that's in there has a certain value to it. Cashews cost more than peanuts do. And probably some of those other exotic nuts cost even more. And what do you notice? You don't get as many of the good ones. Okay? The manufacturers literally do some mathematics to find out what should we charge for this, or they might say, I don't want to charge more than $5. How much of each kind of nut can we afford to put in here? So somebody does some mathematics. Okay, we're just going to look at ticket questions and coin problems. I hope you're going to see some common thread to what we did with the liquids. All right, I'm going to read number 1 in case you can't see it up there on the screen. It says, a theater contains 405 seats. What they don't say is they're going to fill them all. Okay, it's implied. And ticket prices for a recent play were $48 for adults, $23 for children. For one matinee, if the total proceeds were $13,190, how many of each type of ticket were sold? Now, in reality, they just count the tickets, okay? But they're trying to give us an opportunity to learn how to do a mixture problem. So I will reread those details as I start to set up the problem. So I'm going to start with number 1. All right. It says a theater contains 405 seats. Okay, 405 seats. I'll write that down so I have it. And it goes on to say that adults cost $48 and $23 for a child ticket. And the question is, how many of each type did they sell if the total proceeds were $13,190? So sometimes I take a minute and write down all the facts that are in the problem, and sometimes I don't. All right. How many unknown quantities are there in this problem?
4. Oh, no. 2.
2. And what are they?
Adult and child tickets sold.
Right. The number of adult tickets and the number of children tickets or child tickets. Now, since there are 2 unknowns, one of them has to be X. Now, here's something that's a little new about this problem that we didn't run into yesterday. I never read a comparison. Did you ever hear a comparison? It never said there were twice as many child tickets as adult tickets. There were 30 more child tickets than adult tickets. There were 15 fewer adult tickets. I never read that. It wasn't in there. So what do we have? Well, all we have is that their total is 405 tickets. So I'm about to show you a new technique that we didn't go over last time. You get to pick which one do you want to be X and which one am I going to have to figure out. Well, I'd like to be consistent with what I've posted in the written notes, so I'm going to ask y'all perhaps to agree to let X be the number of adult tickets. You could have said X was the number of child tickets, but if you don't mind, I'd like to stick with adult. Now, the question is, how am I going to write something that tells how many child tickets there are? All right, so I'm about to make up a new scenario, so forget about this theater for just a minute. All right, in your mind, I want you to think about a little bitty theater. It's only got 20 seats in it. If 5 adult tickets were sold and there were only 20, how many would be child? 15, and nobody even flinched getting that answer. What did you do? You subtracted. You took the total, 20, you subtracted the number that I told you, 5, and you got 15. Okay, same little bitty theater, 20 tickets, 10 of them were adults. How many were children? 10, and once again you subtracted. All right, now let's go back to this big theater of 405 seats. X tickets were sold to adults. The number of tickets sold to children is, now what process did you use?
Subtraction.
You subtracted. So I would take 405 and I would subtract X from it, and that will tell me the number left over to be the number of child tickets. That is a very, very common technique for deciding a relationship when you don't hear it. You read it and you don't hear a comparison, and you say, well, I didn't hear a comparison, but I did get a total. So if one of them is X, the other one is the total minus X. That's going to be a little skill that you can use in a lot of different problems. Is everybody okay with that?
Yes.
All right, now let's talk about value. I'm ready to try to write an equation. How much money did the theater owners get for every one of the adult tickets?
$48.
$48. Well, if they only sold one, they'd get $48. If they sold two, what would you do? Multiply 2 times 48, you'd get 96. If it was 3, you'd multiply 3 times 48. But you know what? It was X. So I'm going to take 48 times X is going to be the amount of money that we get from adult tickets. Is that okay?
Mm-hmm.
How much did you earn for each child ticket?
23.
23. So I'm going to take 23 times, and how many child tickets did we sell?
405 minus
405 minus X. So it is the individual value times the quantity. You did that back with the liquid mixture. It's just the value was the percentage. Okay? And that equals, this time, super easy because they gave us the total amount of money. How much money? Big old number, 13,000. Whoops. Okay, I'm sorry. Little weirdness going on here. Stop that. Okay, stop that. Go away. I have no clue. Oh, that's not good. There we go. Maybe it's moved. Okay, that needs to stop. Thank you. Okay, got my problem. And I will need to distribute on this left-hand side, so I have 48x plus. Now 23 times 405, I've already done that product. It's 9,350. 23 times negative x is negative 23x. Now, before I say I'm done with that simplifying, do I have some like terms on the left-hand side?
Yes.
I have 48x minus 23x, which gives me 25x plus 9315. So it took me 2 steps, one with the distributive property and one with combining like terms, and the left side is finished, and it's equal to 13,190. What's my next step? Subtract. I need to subtract 9315, subtract 9315 from both sides. That leaves me with 25x is equal to 3,875. And what's my last step?
Divide.
Divide by 25. Divide by 25. X is equal to 155. Now, I'm not totally through with the problem yet, but I'm almost through. What did we just find out?
There was 155 adult tickets sold.
Yes, because X turned out to be 155, there were 155 of the adult tickets. How am I going to figure out how many child tickets there were?
Because 405 minus X is how many child tickets?
Yes, 405 minus X is the expression that I have up here for child tickets. That means that it is 405 minus 155, which is 250. And that will be the number of child tickets. How could you check and see if you're right?
Add those two and multiply them.
Okay, actually I'm going to do it in a little bit different order. I'm going to multiply each one of them by their value. So I'll multiply the 155 times the,
23.
actually it's times the 48, because that's adult tickets. And then I'll multiply the 250 times 23, add them up, and what should I get? 13,190. So is everybody okay with that? All right, let's look at number 2. If I go all the way back up, all right, problem number 2, it says a theater contains 451 seats, and the ticket prices for a recent play were $49 for adults and $28 for children. For one matinee, the total proceeds were $15,883. How many of each type ticket were sold? So I'll write down those facts in case you don't have it. You have 451 seats. You have a price of $49 for adults, and you have $28 for a child ticket. You have total proceeds of $15,883. All right, let's be consistent. What would you like X to represent?
Adults.
Adults. And it's the number of adults. And now let's see if you can use the same strategy you used before. What will you call the number of child tickets?
451 minus X.
Right. The total tickets, 451, minus X, will have the leftovers, which must be the number of children. Now it's time to write the equation. The equation typically has to do with the value or the money. All right? How much does each one of those adult tickets cost? $49. So if I multiply 49 times X, that'll be the value or the quantity that I get in adults. How will I write what I get for children? What's the cost of a ticket?
It is 28,
28. And how many children tickets did I have?
451 minus X.
451 minus X. And what's my total money?
15,883.
Yes, 15,883. And if y'all will go ahead and write that, because obviously I can't. Okay. Yeah. All right, something's a little crazy for me. Would y'all go ahead and solve that problem while I try to solve my technology problem? All right, let's take a look together. I've got my problem worked out that I kind of did in silence, but now I'm going to talk about what it was. All right, the first thing I did was look at the left-hand side, and I could simplify by using the distributive property. 28 times 451 gave me 12,628. 28 times negative x gave me negative 28x. I have like terms on the left-hand side. So I take 49 minus 28, and I got 21x, and I have minus 12,628 equals that total of 15,883. I only have variables on the left, so I subtracted the constant. Subtracted from both sides, I ended up with 21x is 3255 divided by, and I didn't write that correctly, 21 on both sides, and that gave me 155. Now, what is 155? Number of adult tickets. To figure out the number of student tickets or child tickets, 451 minus x, which is 451, minus that 155 is 296. When you do those questions in MathLab, it will ask for those two. Make sure you give the right answer to the right one. Okay, we have one other type of question that's in here, and there are two of these. I think you'll find them pretty easy now that we've been working on this. If I go up to number 3. Anybody have a question you need me to stop? Okay, question number 3. I know it's projected rather tiny on the screen, but I will read it out loud. It says, a youth organization collected nickels and dimes for a charity drive. By the end of the one-day drive, the youth had collected $60.30. If there were 4 times as many dimes as nickels, how many of each type of coin was collected? Now, I'll write down all those facts in just a minute. for question number 3. All right, how many well, no, let's just write it down. We had a total of what, $60.30 collected? And we had some nickels, and we had some dimes, and we've got a comparison between them, I think. Didn't it this time? Do you agree that we're looking for number of nickels and number of dimes? Okay, let me reread the comparison again. It said, it says there were 4 times as many dimes as nickels. Which one's going to be X? There are 4 times as many dimes as nickels. I'm not telling you anything about nickels. So what I'm going to do is let X be the number of nickels. Now, in one way, this is easier than the ticket problem because they didn't give us a comparison in the ticket problem, but they did in this one. If the number of dimes, if there's 4 times as many, how will you write the number of dimes? 4x. And now I'm ready to write an equation, and the equation is going to have to do with value. What is the value of a nickel? 5 cents. Now that's not given in the problem because they assume everybody knows that. Okay, so we know that it is, now you have a choice. It is 5 cents written in dollar notation, or it is 5 cents written in cents notation. What's the value of a dime?
10.
It is 10 cents, which is 0.10, written in dollar notation. It is 10 cents written in cent notation. You have to make a decision whether you want to do the problem in the dollar notation or the cents notation. The cents turns out to be easier because you don't have any of those decimal points. So I choose this notation, which means if I had 1 nickel, I would have 5 cents. If I had 2 nickels, I would have 10 cents. 3 nickels, 15 cents, and so on. I have X nickels. I have 5 times X as the number of cents of value in nickels. Okay? How much is each dime worth? 10. So it's 10 times, how many dimes do I have?
4 times the amount of nickels.
I have 4x. It's weird, but I have 4x dimes. So it's value times quantity. Value times quantity. We've done that in every kind of mixture problem. It is equal to how much?
60.
All right, it is equal to $60.30, but you know what? Yeah, we're in the cents. Somebody brought up earlier in those liquid mixtures, if some of it had been in gallons and some of it had been in ounces, would we have had to convert? And the answer was yes. Well, everything has to be in cents. So although it might look weird, there's 6,030 cents. Okay, I can live with that. 60/30. Don't mix the notations. Don't put these in cents and this one in dollars. It'll mess up. All right, let's finish the problem now. I'm going to keep this. 10 times 4x is 40x, and that equals 60/30. Can I combine these like terms because they are both on the left-hand side of the equation?
Yes.
Yes. So that is 45x is equal to 60/30. And what's my one and only step?
Division.
Division. I'm going to divide by 45, divide by 45, and I get x is, and I've already done this earlier, so I know the answer, it's 134. What did we just find?
If there was 134 nickels.
That there were 134 nickels collected. How am I going to figure out how many dimes were collected?
Times 4.
Yes, 4x is that expression, so it's 4 times 134, which, and once again, I've already done this, it's 536. Are y'all seeing a few common threads in the mixture problems? They tend, when you write the equation, to always be value times quantity plus value times quantity equals total value. Yes?
Like on that problem, it gives you has 4 times x, but on the other one we did, it didn't say nothing like that. How do we know for sure, like on the ticket, how do we know for sure that's how many it's all tickets are sold? I mean, if you don't have any other information.
Oh, okay. If we go back up to these ticket problems, I think I understand your question okay. It was very clear in problem number 3 that X had to be number of nickels. There was no decision to it. But in problem number 1, there was a choice. You got to pick who got to be X. The nice thing is, if you had chosen X to be the number of child tickets, I guarantee you that the answer you would have gotten for X would have been this 250. It will work out no matter what. Okay, I'm just going to have to give you that as a promise right now. Because of what you multiply it by and so on, it will work out. It feels a little bit uneasy when you get to pick what X is. But I promise if you're simply consistent with your problem, it will turn out right. Did I answer your question?
Yeah, it was just like when you pick the one.
You won't pick. Now, in this last problem that we just did, the reason it has to be this way, let me scoot this over a little bit, is because in the comparison it said there are 4 times as many dimes as nickels. Nickels had to be X. When you don't know for sure and you're setting it up like with the ticket problems, as long as you're consistent, it will work out. Unfortunately, you're just going to have to take my word for that right now. Experience will prove it. All right, let's do our last one. All right. It says, and I know it's too tiny for y'all to read on the screen, but it says, a youth organization collected nickels and dimes for a charity drive. By the end of day 1 drive, the youth had collected $37.50. $37.50. There were 2 times as many dimes as nickels. How many of each type were collected? Okay, so if I write down that one little fact that there was $37.50 collected. Now, my unknowns. Do y'all agree that I'm looking for 2 things? Numbers of nickels and numbers of dimes.
Yes.
Okay, there were 2 times as many dimes as nickels collected. Who gets to be X? Nickels again. X equals number of nickels. No real choice on that. How are you going to write an expression for the number of dimes? 2x this time. 2x will be the number of dimes. I recommend that you set it up in cents, but would you set it up? And I'll pause. Okay, if we resume, we're going to write an equation based on value. 5 cents for each of those X nickels plus 10 cents for each of the 2X dimes equals a total of 3,750 cents. I have the 5, the 10, and the 3,750 all in cents. Multiply 10 times 2X to give me 20X. Combine like terms of 5X and 20X to make 25X. 25X is equal to 3750. Divide by 25. You should get X is 150. What do you have if you have X is 150? There are 150 nickels. How do you figure out how many dimes there are? 2 times it. 2X will be 300. Okay. Anybody have a question about the coin problems.